Hello class, and welcome to our Introduction to the Number System lesson. I'm Mr. Hager, and today our learning target is I can define the different types of numbers and I can identify rational and irrational numbers. Okay, so the objective for you guys will be students will be able to define different types of numbers and identify whether those numbers are irrational and rational. Okay, so we'll go ahead and start with our Introduction to the Number System lesson. So what a better way to start than to back it up all the way into prehistoric time. So even in prehistoric times, we used methods of counting numbers. For an example, cavemen or prehistoric humans would, in order to determine how many days it had been since a significant event, they used numbers. So if it rained on this day, and it didn't rain on this day, 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 but it rained on this day, it rained on these 2 days, they would use this as a measurement to see, for subtraction, to see how many days it had been since it had rained. So it had been 1, 2, 3, 4, 5. So look, we got 1, 2, 3, 4, 5, 6. Minus 1 equals 5. So it had been 5 days since it had rained. We had 6 total days, and it had been 1, 2, 3, 4, 5 days since it had last rained. And see, this is practical. This is practical for smaller quantities, but if we was doing a crazy amount of number up into the thousands and 10,000s, 100,000s, and millions, we couldn't use this method. So for that, we developed number systems. And so number systems there's two main types of ones. The number system that we're going to deal with is the base 10 number system, and that is the number system that we use. The reason why we call it the base 10 number system is because there are 10 digits. There is a 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Base 10. And what's convenient about this base 10 number system is the fact that we have 10 fingers and 10 toes. So it's easy to bundle. It's easy to bundle in groups of 10, okay? So the number system we use is the base 10 number system, and that's important to know. So an example of how we use the base 10 number system would be if I had a number such as 321. So one big concept in number systems is place value. And we have to know what place value these numbers are in. Okay, so this 1 is in the ones place. This 2 is in the tens place. And this 3 is in the hundreds place. Okay? So an easier way to write this is we can do it numerically. So we have the ones place, we have 1, 1. So this is the same as saying 1 by 1. Okay? Tens place, we have 2 times 10. Because there's 2 tens, so 2 times 10. And there's 300, so 3 times 100. Okay, so that's number 321. Let's go ahead and solve these, okay? 3 times 100 is 300. 2 times 10 is 20. 1 times 1 is 1. And that's going to give us our 321. So it's very important to notice the place value of all these different types of numbers because that'll be crucial in determining what number it is. Now, we're going to get into the different types of numbers that you'll deal with. The first being the natural numbers or the counting numbers. natural numbers they're sometimes called counting, so I'll put in parentheses. Sometimes called counting numbers. So I'll accept either of these, natural or counting. An example of these numbers is like 1, 2, 3, 4, 5, on and on and on and on. Only the positive numbers, not 0. 0 is not included in a natural number or a counting number. The second type of numbers that we're going to be going over is the whole numbers. The whole numbers the whole numbers are all the numbers that we just included in natural numbers plus 0. So it's like 1, 2, 3, 4, 5, but you're adding that 0. In some higher level math courses, some high level mathematicians will just completely get rid of the natural numbers in general, because the only difference between whole numbers and natural numbers is this 0. So some of them will disband it completely, but this is the whole numbers. Okay, the next type of numbers that we will deal with are the integers. Okay, so integers are all the positive numbers and their negative counterparts. So for example, we got like -3, -2, -1, 0, 1, 2, 3. So these are integers. It's all the whole numbers and their negative counterparts. All the whole numbers and their negative counterparts. Okay, the next up, we have rational numbers. Rational numbers can be spelled that wrong. I'm a math teacher, I'm not an English teacher. Rational numbers can be written as a ratio, a fraction, or a terminating decimal. So for example, rational numbers can be the square root of a perfect square, so such as 4, square root of 9 is a perfect square, square root of 16 is a perfect square. So the square root of a perfect square is an example of a rational number. Also, some examples of rational numbers that aren't perfect squares are just a simple 2, because it can be 2 is a rational number because it can be written as 2 over 1 as a fraction. 1/2 is any number that can be written as a fraction. So 1/2, 3/6, 4 over 100 can be written as if it can be written as a fraction, then it's a rational number. Okay, so even terminating decimals. So 3.213 can be written as a fraction because it's a terminating decimal. So therefore, it is a rational number. Now, an irrational number. Now, I'm just going to go and put an R up there. An irrational number is a number that cannot, a number that doesn't terminate or repeat. It goes on and on and on and on forever, and it can't be represented as a fraction. So it's a decimal that goes on and on and on and on and on and never stops. It's non-terminating and non-repeating. Okay, so an example of this would be the square root of any non-perfect square. If it's not a perfect square and it's up here, then it's an irrational number. Okay, so the square root of 2, 2 is not a perfect square, so it's going to be irrational. Okay, the square root of 50 is not a perfect square, so it's going to be irrational. Another example would be pi. Pi goes on and on and on and on and on forever, and it never stops. So it's an irrational number, okay? Now I'm going to get into where all of these kind of mix up, okay? So first off, down here, we have the natural numbers, okay? So I'm going to put this little circle right here, and these are the natural numbers. The number, or the symbol for natural numbers is n, okay? Next up, we have the whole numbers, and these are like 1, 2, 3, and so on. Next up, we have the whole numbers. Whole numbers are represented by W for whole. And this is everything with the addition of 0. The 0 is very important. So 0, 1, 2, 3. Okay? Next up, it's not a very good circle, but next up we have integers. Integers are, now this is going to seem kind of weird, but you need to know that integers is not represented by an I, it's represented by a Z. Z. Integers. And we'll go over that more because I know it's kind of confusing because, you know, integers you think I, but it's actually Z. And these are all the negative, it's all the positive numbers and their negative counterparts. So -2, -1, 0, 1, 2, and so on. Okay, next up we have rational numbers. Rational numbers are represented by a Q. And I know that's going to be kind of confusing for you guys too, so once again, we'll go over this more in class. But the reason why we represent integers with a Z is because irrational numbers is represented with an I, because it's a bigger subset. And rational numbers is represented with a Q because we classify real numbers with an R. So rational numbers is with a Q. And these are like, and the reason why this is so significant is because natural numbers are inside rational numbers. So all natural numbers are rational, all whole numbers are rational, all integers are rational. And that's why we make this diagram, so I can show you, kind of visually give you guys a representation of what it actually looks like. Okay, so rational numbers, anything that can be written as a fraction. So technically, all these numbers can be written as fractions because they're whole numbers and they're integers. So, but I'm going to give you guys examples of rational numbers that aren't whole. So like a fraction like 1/2, the square root of a perfect square. So square root of 4 is rational because the square root of 4 is actually 2, which is a whole number. Okay, so anything that can be written as a fraction, and then we're going to go 3.3 repeating, because 3.3 repeating is the same as 3 1/3, and that's a fraction. Okay, so next up, we're going to be drawing this little box thingy. Okay, so now over here, we're going to have I, which is irrational. These are the irrational numbers, and they're represented by I. Irrational numbers are numbers that don't, they never end. You know, it's a non-repeating decimal and a non-repeating decimal, a non-terminating decimal, and it can't be written as a fraction. So it goes on and on and on and on forever and never stops. So some examples would be the square root of 5, which goes on forever. Square root of 33. You got pi, and you got e. You know, some of those mathematical terms that we use every day. And then these are real numbers. So these are real numbers, and we classify all real numbers as all irrational numbers and all rational numbers. This is one of the main things, the most important things that I want you to get out of this.